Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you very much, Anna. A very good day to everyone, and thank you very much for joining today's session. Welcome to the AI for Good Machine Learning 5G Challenge webinar session. My name is Thomas Bascolo from the International Telecommunications Union, ITU. The Machine Learning in 5G Challenge aims to create a community to solve network-related problems using AI and machine learning. Today, we are excited to host another interesting session. It's a webinar that is under the 2022 ITU AI/Machine Learning in 5G Challenge problem statement. And this problem statement is titled Synthetic Observability Data Generation Using GANs. As always, we are counting on you, our participants, to help create an engaging discussion. If you have a question, please type it in the video wall, and we will take the questions during the Q&A session after the talk. Now, I would like to introduce today's speakers. Today's talk is going to be given by Sridhar Rao from Linux Foundation Networking, Lei Huang and Kai Lu from China Mobile Research Institute. They will discuss synthetic observability data generation using GANs, which is a problem statement for the 2022 ITU AI and Machine Learning 5G Challenge. In this challenge, participants are challenged to obtain real-world data set for AI and machine learning model development and testing for network function virtualization, NFV, use cases. So this will be done by generating observability data using GANs. This talk will elaborate on the problem statement to explain in detail the data set and also discuss why GANs can help to solve this problem. So without further ado, I'd like to welcome our first speaker, Sridhar. Good evening, Sridhar.
Hey, good evening, Thomas. Thanks a lot for this nice introduction and welcome. So thank you very much.
Thank you so much. Please, the floor is yours.
Okay, so I'll share my screen. I hope you all can see my screen, right? Yep. So good afternoon, good evening, good morning, everybody who are joining from whichever part of the world. Thanks a lot for this opportunity and really appreciate this thing. And when it was first mentioned AI for Good, I mean, we have to do this kind of a thing. We had to join this group and take up this, become a host in this AI for Good challenge. Okay, so in this talk, I'll be describing more about the problem and the data that we want to generate using GANs. Okay, the flow will be, we will start with a brief introduction including the speakers, the data, the domain, and the availability challenge. Considering that some of the participants may not be aware of the domain, I would like to give a quick overview of the domain and describe the availability challenge, data availability challenge for telco use cases, which is actually the motivation of this whole work. And we will describe the solutions to overcome this problem and why we have chosen GANs. We will give a detailed overview of the target, the data set that we want to generate using GANs. We have a quick introduction to GANs by Lei Huang. And finally, the logistics and the closure part. Okay, so before I start, I just want to introduce the host of this problem. So it's a combination of Linux Foundation's Anuket Thod project. So under Linux Foundation, we have Anuket project, which is an umbrella project under which they have multiple sub-projects. One of the sub-projects under this Anuket is Thod, which is AI and ML for NFV use cases, and China Mobile. So we have, in this call, we have Liu Kai and Lei Huang from China Mobile. In fact, Lei Huang is also the PTL of this Anuket's Thod project. I am one of the participants of the Anuket Thod. Yeah, before I start, I would like to thank ITU AI for Good for providing us this opportunity. This is a sincere thanks from our side, and Intel for providing the test bed in the LF networking shared test beds, and also all the members of the Anuket Thod project, Verizon members, the VTU, and extra. So thanks a lot to all of this. Now, I just want to set a stage. So this is our first webinar on this problem, and we both the China Mobile and LFN would want to do more, follow up with this more such tech talks. And participants are free to join Anuket Thod meetings for any quick clarifications. So what we do, we meet every Fridays exactly the same time, like 6 a.m. Pacific time. Right. So I'll just share a link for the Anuket Thod meeting. I just want to give us, I think Thomas already mentioned. So myself, I'm Sridhar. I'm working with the Linux Foundation as a technical architect, community architect. We have Lei Huang, who is a researcher and who works with the research center in China Mobile Research Institute. She's working on this core AI and ML research in China Mobile. And also her colleague, Liu Kai, who is also in the same research center working as a researcher, and his research interests are mostly in network intelligence and compute force. Okay, just a quick summary. As they say, this is kind of a take-home kind of a message from this talk. This AI research in NFV requires a large amount of real-world NFV telecom data from telecom networks. Kind of thing. And it's very difficult for non-operator personnel to obtain this data, right? And in order to solve this problem, we chose AI approach to generate an observable data, a synthetic data. And this is the main message of this talk, and I will elaborate on this summary. Right. So in this AI for Good ITU challenge, we recommend using GANs for generating the infrastructure metrics. So I'll walk through what is this infrastructure and what does it mean. I will also have a quick overview of NFV also. And we will first explain why it is difficult. I just mentioned it is difficult to obtain. I will elaborate why it is difficult to obtain. Okay, so let's start with the data, the domain, and the challenges. So when I say the data, right, I think we all are familiar in this call who have been working in this domain of AI and ML. I'll just give a quick summary. If you look at the learning components of any ML problem, right, any ML thing, so we have an unknown target function. Again, this model is from Caltech Professor Mustafa. So we have this unknown target function f, and this will always remain unknown, right? And based on the training examples that we have been provided, we try to come up with the final hypothesis f, I mean G, which should mirror f, or it should be almost equal to as f, right? So that's the whole goal, and we do it by coming up with a learning algorithm. And how do? We just don't randomly pick, right? We consider a hypothesis set from which we pick a right algorithm and come up with the final G that should be as close as possible to F, right? So this is a very generic model. And once we have the final hypothesis, we can test it on using a testing examples. So this is what we are referring as the data or the data set in the stock. So I just wanted to set the clearly what do I mean by data or data set whenever I'm speaking in this session. Okay, and again, another thing, what is the scope of this whole work, right? So when we talk about AI and ML problems in the telco domain, it's a huge, when consider the 5G, I think when Thomas was talking about it, there are a lot of AI and ML applications in the domain of 5G. You will come across a lot of works. I think even within ITU for good over last 2 years, we have a summary of some of the problems that has been solved in the domain of 5G. You would have seen a lot of works in the radio access networks domain, right? So within the 5G, there is also a subset which we call it as an intelligent networking domain, right? And within that intelligent networking, we have the subset is NFV, right? So this is the scope of this whole work, this I'm generating it, because the observable data or the infrastructure metrics that we are considering applies to the subdomain of this NFV. So NFV is an abbreviation for network function virtualization. Now, what is this? Let me give a quick overview of what NFV is, right? So typically, I mean, over like 15, 20 years back, or maybe before that, you might be aware of these network devices. They are referred as network functions because there's certain a particular network functionality of network is running on these devices, right? All these devices were physical devices. They were boxes, right? And whenever the telco wanted to come up with a newer version or update it, they had to buy a new box, right? And this hardware consolidation was really a big challenge for these telcos. So everything was a separate box, and every upgrade needed a new box. Now they maybe around 2013 time, 12-13, where the people came up with the idea of, hey, how about we take all these boxes that are there in physical and run them as on commodity off-the-shelf servers, right? When the virtualization was doing very good and its peak, and all these servers were doing at a very good performance, they thought of, hey, why don't we move these things and virtualize it and run it on these off-the-shelf servers? What do you mean by virtualize it? Run it on virtual machines, or even over past few years as containers, right? So this idea of taking these physical boxes and virtualize it and running it on this commodity and off-the-shelf servers is what, at the very high level, what NFV is all about. Right. So there is the philosophy similar to the SDN separation of hardware and software is still do you see here in NFV also, right? And once we have these virtual machines and this commodity off-the-shelf servers to manage this multiple virtual machines and infrastructure, typically we have a bunch of managers and orchestrators. Okay. So I'll just move this down. Yeah. So when I refer to orchestrators and managers, you would have heard of OpenStack, Kubernetes, or VNFMs, and these kind of managers and orchestrators that I'm talking about. Okay. So this is a quick overview of those who are not aware of what NFV is. This should help you to understand what we are talking about. Right. So we'll be focusing on these commodity off-the-shelf servers on which you will have a virtualized network devices running. Okay. Why NFV is important? If you consider any telco's growth, right, whether it's starting from 2G, 3G, 4G, and 5G, they typically focus on these three dimensions: the mobile technologies, the operations, and the devices and the services. Okay. And when it comes to specifically the 5G, the last layer, the services, right? I think you would have seen this what kind of the newer services that have been coming out. These services are the ones which are very critical in 5G. You would have seen throughout the world, the telcos are introducing, I mean, very interesting services and offering these kind of services to the end customers every other day. Right? So NFV helps you to get here. Okay, so it has become a very critical component of this 5G solution. Okay. So what is how is today the AI and ML is used in NFV world? I just want to give a big picture so that you can understand. So if you consider this cloud environment with a bunch of like a data center with a bunch of servers that are running, we have underneath the agents or kind of a set of things collecting all the data from these multiple systems. It could be a physical network devices, it could be the servers, or it could be the services that are running, the bunch of SDN controllers, test frameworks, and managers and orchestrators, right? On each of these components, they're generating the data, right? So this data is transported through any of these mechanisms. It could be TCP, UDP, or ZMQ, zero message queues, or it could be even the message queues like Kafka or RabbitMQ, bunch of transport mechanisms. And on top of that, we have this aggregation layer, which collect all these kind of data and keep it in the databases, and in turn expose for any further processing. Okay, and finally, we have a top layer with the data analytics part. Here, this is where we run all the algorithms and ML and AI/ML solutions are run. So, but the focus of this session is about the virtualized infrastructure agents that are run on these kind of servers. Now, there are so many agents, the open source monitoring agents that are available today. If you see these, I'm just giving us, there could be even more. This was the last, when I did a comparison of, you can see in this link, I have published this monitoring agents comparative study. And we found that CollectD, in fact, in Anuket, we have a separate project called Barometer, which works on this CollectD thing, which is most popular and most commonly used in the world of NFV. So we will be focusing on this CollectD data in this work. Okay. Now, has AI and ML for NFV has been used? Are there any problems already? Yes, of course. There have been a lot of work that has been there. We have published, in fact, done a nice survey of all kinds of problems that has already been worked upon by the academia. Excellent work by the academia on this thing. I just want to summarize here into 3-4 buckets. The first bucket is detection and analysis. So there are a bunch of problems on finding the patterns, the trends, and doing the correlation part, and also the finding the anomaly detection and the causality analysis kind of thing, right? And the next is the predictions. So there have been very interesting works on failures prediction, but mostly around VM failures. We didn't find much on some of them are the links and services, but not on containers or other applications. And there are very good work on resource availability, where, for example, traffic engineering, application placement, auto scaling, SLA management. These kind of resource based on resource availability, very interesting problems have been worked upon. And also the alert management filtering and the capacity planning. And finally, as I mentioned in this link, you can, as part of the OPNFV Thought, we publish this research studies regularly. And in this first release, we have published all the AI and ML problems that are used in NFV domain. Okay, but what is the data that is being used in these NFV, AI and ML for NFV domain, right? The answer is very simple. It's metrics and logs, right? So it's a huge set of metrics and the logs that have been generated on this system. At times, we can also use a per component statistics, for example, a virtual switch or SDN controller or managers and orchestrators, but predominantly it's from metrics and the logs, right? But in reality, it is not so simple. For each of this problem, especially in the NFV domain, it is not at all straightforward, right? What are all the metrics and what are all the logs to use? And what are all the component specific stats? It's still a very open problem and a lot of scope for the research, any researchers out there. I just want to give an example, taking a failure prediction data, right? For example, if you take a failure prediction, we have different types, the links, VMs, containers, node, and application, right? Now, how do I decide whether it's a failure? For example, in link, it could be down or removed. In VMs and container, it could be failed to start, failed to boot, shut down, crash, hang, panic. Similarly, it could be different types of parameters to decide whether the failure has happened. Now, where do this failure data exist? it could exist in the logs, right? If it is an OpenStack environment, it could exist in these logs, or if it is a Kubernetes environment, it could exist in these logs. And finally, we can use the metrics. And in metrics, it's a lot of infrastructure metrics. For example, today, if you find in academic, the published research in failure prediction data, logs are not used in, I think. The most of the things that are used are metrics. They infer the failure from the metrics, which is not like 100% correct, but what to do? That's the situation is like that. The availability has been a real challenge. Okay, and why the problem? We have this availability problem, right? Obtaining a real world data, especially the metrics, logs, and statistics from a real world NFV environment is very, very difficult. And especially for those who are not part of service providers, for like open source community or academia, and for them, it's very difficult. Why? The two things, the nature of the business and the nature of the data. As for the telcos, right, it's very, very difficult for them to share this data because they have a lot of policies, rules, and regulations that they have to adhere to. And opening up this data is extremely difficult, challenging for them. And also considering the nature of the data that can contain sensitive information, right? And because of the policies and rules and regulations that when sensitive information is there, sharing any even remotely connected thing becomes very difficult for them, right? So that makes extremely tough for these telcos to share this kind of data. So, for example, even you would have seen over the last 2 years in AI for Good ITU, when some of the telcos have shared the data, even that was not exactly from real world environment. It is emulated of the real world. Even though how close, if they say it's closely, emulation is very, very close to the real world, but it cannot be real world in most of the cases. Now, how do we overcome this this challenge of the data, right? So there are the bunch of approaches that we considered over last few months, or in fact a year, more than a year, in fact. And I just want to summarize here quickly. Use an existing ones. So I will quickly show this thing. I'll just put a link here. As soon as this talk, I will show the list of the available data that is available. Right. In fact, even with ITUT, the previous years also, there are a bunch of data that is available. We have documented and listed that also. I can share that summary of that list. And the next is collaborate. This is what we have been trying to do. Let me move this. I don't know where to do that. Okay. So we have research labs and operations teams with telcos or with other vendors and service providers, or LFN labs, and also especially the other open source projects that have test beds. Like for example, in OpenStack or Kubernetes community, they might be having some open source projects, they might be having some test beds. So we try to collaborate with them and request for them to share the data set, right? And the next is test beds. We ourselves set up the test bed. This is what we are doing for now, thanks to China Mobile. So they also set up a test bed specifically for this thing. Both Lei Wang and Lukai can tell more about that. And they have also come forward to share this data that they have set up the test bed for this particular work. And it could be OpenStack or it could be a Kubernetes test bed. It doesn't matter, especially for the infrastructure metrics, because these metrics are more or less the same. And we have used open source tools to emulate the workloads, right? Because this infrastructure metrics won't change unless there are some workloads are running on it, right? So we create like open source tools like StressNG and these kind of stressor tools to emulate the workloads. We also have an option of simulators like NS3 or network function emulators or other open source simulators. And another thing which has a scope for research, right? Anonymizing the data. So this is one of the work that we will be considering in Third. So if there are any volunteers out there who want to contribute to this project, this is one work which has a good potential for research. How do we anonymize the data so that the telcos can come forward and share it with the others? Right? It's a challenge. It's an open challenge thing. In fact, we can use again some of the data science frameworks that are there in Python and like TensorFlow and other kind of solutions, which we can use it and try to anonymize the data. And lastly, that the one that we are proposing in this work is use AI and ML itself, right? So this is where we propose to use GANs to generate a synthetic data, right? And we all know GANs is first to generative adversarial networks by, I think, around 2014, Ian Goodfellow proposed it. Li Huang will be talking more on this in coming slides. And it's been applied, you all know that it's been applied to generate image data, right? It's very, very popular when it comes to generating image data. But where can it be applied to generate time series data? There have been some work around this generating time series data using GANs, but not much compared to the image thing, mainly because it's difficult to evaluate the quality of it. Now, if we are successful in generating the infrastructure metrics using GANs, it can open up various use cases. Believe me, we have discussed this with a lot of other telcos, and they're of the same opinion. Now, let me walk through the target, the data set that we want to focus. As I mentioned in the beginning, it's about the collect-D. Okay, so I just want to give what is this collect-D, right? So this is one of these agents that sit on any of the systems. It could be any computer, it could be any Linux system, or any system, even as on a virtual function of network function, or the physical, the hardware, or the host system. Right. The idea is very simple. It has a bunch of plugins, right? And the core engine. So the plugins are categorized as input plugin, output plugin, and other plugins. I'll come to the other plugins also. So the idea is the input plugins are the ones which reads all the data from the system and ask the core engine to dispatch these values, and the dispatcher will take control of all the output plugins, or usually the output plugins are also called as write plugins. Read plugins are also called as input plugins, are also called as read plugins, right? So it's a collection of plugins managed by the single daemon. The input plugins, as I was mentioned, the output plugins, and we also have the binding plugins, which gives the language bindings. You can talk to the system using Python or C or any other languages, and there are also logging plugins and the notification plugins. But your focus should be mostly for this to understand this tool is input plugin and output plugin, right? It can also write to the message queues or even to SNMPs. If you see the number of write plugins or the output plugins are really, really good, none of the monitoring agents can match the number of plugins that collect-D has, right? So yeah, so it supports push-based mechanism. There you would find some of the things that are pull-based thing. If you want to add a pull-based solution here, you can consider pushing it to a message queues and pull from the message queues. That is one of the options that we have used sometimes, right? There are some plugins which can do both read and dispatch. Right. Now, how these data that are collect-D, when it collects and writes it into, for example, when we are sharing the data with all the participants, we are using the write plugin of CSV, right, comma separated values, and we have shared this data with all the participants, or rather, we will be sharing data with all the participants. So this data will how this data will look and what this data is about is what I'm going to cover in the remaining part of the session. Right. So when you see the comma separated values, we have a bunch of columns. The first column is always the timestamp, right? It's in the epoch mode. You can convert it into daytime, month, and all the hour, second, minutes kind of thing. And the remaining columns are what the values that collect is reporting. Okay. So now what are these values? if there is a single value, the column name is always value. But if there is more than one columns, the name will be the data source. Now, what is this? I will explain with an examples, right? And with these values, they're categorized into 4 types. The derive. So these are the ones where it can change over a period of time. And if you want to calculate and store the rate, then we use the derive thing. Okay. The counter are similar to the derive, but it can wrap around. There's the gauge is for value that is stored. It's as is. You don't do for any modification. Okay, and if you the 4th one is the absolute one, is similarly used for, very similar to this thing, used for counters, and it can also consider the value list. Okay, now what are these types? We don't have to. Luckily, Collective project has documented this very well in this links. There's a types.db. Each and every type has been explained with the value type, the max value, the min value. And if there is no max value, you will find the letter U in it. In this file, if you go to this file, you will find some places that is mentioned as U. That means unknown. It can take. There is no limitation. The maximum value is not checked by the daemon, right? It can go. There is no limit for that such kind of. So it's mentioned as U or unknown. So I just want to share examples with the slide. I will also do a quick walkthrough of the data. See, for example, this is for the CPU user type, right? So we have epoch and a value. As I mentioned, if there's only one column after the timestamp, the heading will be value. So if this is an example from one of the nodes, how the values can vary depending on a single node. This is for like almost 7,300 seconds, how the CPU user values have been changing, right? This is another single column for a free memory. So if you see, the data set is good here because the value can range from 0% to 100%. Right? And you will see more or less the data set is present in all the things. So this is a good data set from a generating point of view, because you will understand what kind of values it can take, right? Had the data been like varying very less, then that may not be a kind of a good data set for you to do the synthetic data generation. Oops, some animation. So similarly, we can have multiple columns. So as I mentioned, if there are multiple columns after the timestamp, it takes the name of the data source. For example, this one is the interface data. So we have RX and TX, receive, transmit for any interface, right? So this is the number of packets that get received or transmitted. So this is the plot. Because the receive and transmit are put in a single plot, you would see that there's like a variation is very less here. Similarly for load. So on this load, if you see there are 3 columns apart from the timestamp, and the headings are short-term load, mid-term load, and the long-term load. And this is an example plot of the data, right? So this is how typically the data will be. So I'll do a quick walkthrough. Before that, I just want to summarize with this image. So in any folder that we share, right? Typically, it will be starting with the CSV. Under that, you will find the name of the host or the system, right? And under that, you will find different categories of data. For example, CPU, the disk, the interface, the load, memory. It could be process. There are other things. Okay, and under these, there'll be a different thing. For example, type and the source. Here, the type is, for example, if you are publishing it as a %, the type will be %, and the source, it could be user, system, and like that. Similarly, for the disk or for the interface, I'll just give an examples below. See, for example, the type is %user, %system, %nice, and like this. Similarly, for the disk, it could be IO time, disk ops, disk time. For interface, it's interface drop, errors, octets, packets. these four. And the load, it's usually the load and the value of the load that you just saw now. For memory, there could be memory buffered, free, and maybe 3 or 4 more, right? So I'll just do a quick walkthrough of this data. I had mentioned that I will show the data set that is existing data set. So this is in the link. If you go in this link, you will find the summary of the data set that is available as of now freely, which you can download it. Okay, and some of them, as I mentioned, it was part of the ITU's the previous year's data set. Okay, so I'll just take a minute to walk through the data here. So when you download, as I mentioned, this is the name of the node, right? This is the name of the node, pod 18, node 4, and the CPU number. So it could be any of the CPU numbers here. So if you see, and I also have the disk free, different partition names, right? DF thing, or similarly, we have the disks, different disk, SDA, SDB, like that, and also the interface. So this is the Kubernetes environment. It's okay if you are not really familiar with the Kubernetes, and hence you will see a lot of virtual interfaces. So you don't have to worry about, you can focus only on the physical interfaces. And we have IRQ, load, memory, process. So I'll just go to a simple example, CPU, which I was showing, maybe 10. So if you see, we have % idle, interrupt, nice. So this is very, very similar to when you run a top command in Linux, how the CPU statistics are shown, right? So we have different statistics like this. If I open any of these files, so here you will find these things, right? So, so how it kind of changes and varies. Okay. Similarly, you can open all of these are very similar to that one. So I can open any of the interfaces which I just showed. Maybe I'll open a physical one. So you will see files like this. Okay. So a number of octets or packets you can choose. Okay. So if you see RX and TX like this. So when you get the data, this is how you should follow the hierarchy, and your system should use this data and understand the data model automatically. Okay, and also for the load, as I said, it's just a single file, and you will find these things. Okay, and finally, I will also just quickly show the memory. Yeah, the buffered, cached, free, slab reclusive, slab under. All these things are very well explained in the collect D documentation. You can just go to the collect D and you will find that all these things very, very nicely explained. Okay, let me come back to the slides. Okay. Okay, now I will pass it on to Lei Huang in this call to give a quick introduction to GANs. Over to you, Lei.
Thank you, Sridhar, for the very good introduction. And this part is the introduction of GAN algorithm. As you know, that the GAN algorithm is called generative adversary network. It consists of generator and discriminator. As shown in this figure, the generator is responsible for generating data, which we call fake data. And the discriminator is responsible for judging whether the real data and the fake data are true or false. Through this constant gain between the generator and the discriminator, the generated data, or we call fake data, will be infinitely similar to the real data. And we have already put the earliest GAN paper on this page. You can download and read this paper and have a more in-depth understanding of GAN algorithm. And also, yes, this page. In order to adapt to different model training demands, GAN has produced many variants. In this competition, we allow everyone to use different variants of GAN algorithm. And next page, please, reader. Yeah, and as shown in this figure, in this task, we recommend all of you to use GAN algorithm, include variants to perform data feature training based on the matrix data collected by collect D and output relevant data model as shown in this figure. And that's all of the introduction of GAN. Okay, back to Schrader.
Okay, thanks, Lee. Yeah, so this is a tentative timeline from based on our understanding. So we're kicking off now in this call, and it's all been published over, I think, 2 weeks back, and the competition started, and we have explained this problem statement now and given a brief introduction. As I mentioned, we would want to give more and more sessions like this. This, I think the competition phase, how it goes, and the deadlines are already published on the ITU website. We don't have to maybe replicate it here. And this is how the thing, and maybe by end of this year, we will have the final thing. Okay, but the important point I would like to highlight here is to all the participants, feel free to join our weekly meetings so that we will be there, both me and Lei Huang will be there to answer if you have any questions around this. Okay, now how to download the data. So we were exploring different options to store the data. We have actually stored, we have put in LFN's Google storage. We were checking how do we give access to all the participants to this Google storage. I think one option is to do the web based access download from the Google LFN's Google storage. So we are preparing. I think by today we should be ready with that. We also considering the GitHub to upload it to the GitHub, and in fact we can also upload it to the AI for Good storage repository, which I think which is also a very good option. But we haven't finalized in a single thing, unfortunately. But definitely in 2 or 3 days, we will share all this exact location details with all the participants. Maybe we can provide multiple options for the different users to download the data. And believe me, in 2 to 3 days, we will have all the data ready. Okay. So thank you. I think that's all we had for the presentation. Now we would be more than happy to start answering questions and discuss on this problem statement.
Thank you very much, Shrida and Lei, for a nice introduction of the problem statement. Right now, we are going into the Q&A. So I would like to invite my colleague, Vishnu. Good evening, Vishnu.
Thank you, Thomas, and good afternoon, good evening, and good morning, colleagues. Thank you, Sridhar. Thank you, colleagues, for that excellent presentation. I remember some time back when we were discussing with Sridhar on various ways in which we could get this off the ground, and here we are. Yeah, thank you so much for all the colleagues who worked behind this. And what a problem statement! I think we have this backed by a project that you are doing. So that's excellent combo, I should say, where we have CMCC, we have a top project, and you are backed by a well-backed group, I should say. Yeah, questions about the platforms which the participants should use. When I say platforms, that means machine learning platforms, the training platforms, tool sets. Do you have any suggestions? Would you like to give some hints or suggestions for the participants on what kind of tool sets they should use? They should use TensorFlow, Keras, I don't know what, PyTorch, PyCaret, AutoML, whatever you throw, please let us know what kind of tool sets are available. Any hints that you would like to give from your experience of playing with this data?
Yeah. So, I mean, we don't want to restrict to begin with. Hey, you should use this and that, but we can give the hints. For example, recently last week from Huawei, we had an excellent presentation on Mindsport, if I'm correctly pronouncing it, and its performance was very good compared to the. It's very similar to the Keras thing. But yeah, either you can use Keras, which underneath uses TensorFlow again, or you can use the Huawei's Mindsport. So these are the two things that I can suggest for users, mainly because the number of the algorithms that are being supported in these frameworks. But ideally, if you can stick to any of these kind of popular frameworks, that should be good.
Excellent.
I think I can share the link of the Mindsport and also the presentation from the Huawei. It has been very good.
I was just going to ask that. Yes, thank you so much. Yes, I think that will be very useful. And of course, we will trouble you again. We will come back to you with many questions later as well, and we will have follow-up sessions. And as you rightly mentioned, I mean, this can be taken up in your project meetings as well.
Exactly.
So I think there is a good amount of opportunity to continue the conversations, and we would like to follow this up. Maybe this is a good thread to follow up. Yeah. Second question, how do you score? So we would, let's say I'm a student or a company employee, whatever I am. I would like to participate. I want to register for this challenge, and I would like to win. Win the challenge. So now, what should I do to win the challenge? So I should know what is the weightage that you would give for what part of my solution, and from our experience, Thomas knows it very well. From our experience, the participants are really clever people. So they would look at how you are going to judge it, how you are going to evaluate it. Could you explain how you are going to evaluate it, and how can I win this?
Exactly. So that is where I will allow Lei Huang to elaborate. So that is where CMCC's work research comes into picture, especially from the discriminator part. When you want to evaluate the quality of the work that has been generated by the participants against the data. So their discriminator model that they're working, and they will be ready soon. I think maybe Lei Huang maybe can elaborate on the discriminator part. That's where the real assessment of the quality of the generation comes into picture, right? From comparing the fake data and the real data. So based on this scoring from these discriminator thing, we plan to evaluate the work from the participants. Lei, you want to add anything on?
I think you have already say all the things. Yes, we will try to do the discriminator to do the evaluation work, and we will also put forward our assessment method after the kickoff of the competition.
Yes.
Thank you so much, Lei and Sridhar and colleagues for doing all the hard work. And there is. Let us step back a little bit just for the time being. I want to step back from the challenge. Maybe before that, one more question about the problem statement itself. What are the prices? So, for example, ITU has its own price. I mean, we do give price. I think Thomas will talk about it. We do give our price. Of course, our top winners get certificates from ITU, and this has been a well documented process. We are in the third year now, and we have that process. But from your side, what can, again, from the participant shoes, I'm saying, what can I look for when I participate in the challenge? Can I look at guidance? Can I look at certificates? Can I look at internships? Can I look at some kind of incentive? What is that I look forward to as a participant when I win this challenge, please?
Fantastic question, and very good question. Thanks, Vishnu, for this. See, we have been thinking about this lines for the last few months, and we have been talking to different the stakeholders in this problem, right? So we have Linux Foundation also, and certification from both this Linux Foundation. Also, we have an excellent research center who is part of this problem host, the China Mobile thing. So we haven't finalized yet, but we are working individually, both from the Linux Foundation side and from China Mobile side, what kind of certification, or maybe from the Linux Foundation, any like kind of a tangible prize that we can give to the participants, to the winners, basically. But that is one side, the tangible benefits, and the certification is the another thing that we want to provide from both the Linux Foundation and also the China Mobile side, if possible. And the third part is basically also these participants, when they work on this telecom problems, they also in this, as I mentioned, invited these participants to join this kind of meeting. They get to meet the real telco researchers also who are working on this domain. So they very good exposure, and maybe meeting with these kind of researchers also from the telecom would be an excellent exposure for them, and also taking maybe an option, connecting, building their network among these researchers in the telco, which is actually a very more beneficial than the other two, which from personally I say, because working with, for example, Li Huang's teams or Verizon's or Telecom Italia, or there is another AT&T. So with these kind of researchers from these telcos, it's a very good learning experience for the students. As you mentioned in this thing, there might be students who might be participating. That would be, I think, better than the first two, I would say. But coming back to the first two, we are working on it, and we will update as soon as possible.
Thank you so much. Yes, I believe, personally, I would say that I would give anything to work with you guys. I know that you guys are the experts in this field, and the guidance is very rare, and we would like to, I'm sure our participants would like to take benefit from it. There is a question from Mohammad Khalik. He's asking, could you please comment on the application of GANs and spatio-temporal setting? Application of GANs in a spatio-temporal setting. Maybe they would like to take that, please.
Or Sridhar, would you like to take this question?
Yeah, see, when it comes to the application of these GANs in this thing, right? Though it's not really related to this, it's just, of course, we are mostly focusing on the temporal part, the time series. These are all the time series data. So in this problem, we will mostly focus on the time series data. And there have been applications of these GANs in this time series data, and especially the type of GAN that has been explained. We can share the, till now, as I said, over past 8 months, we are working on this problem also in the open the TOTH project. We would be more than happy to elaborate on the specific types of the GANs and this which application area it can be applied, especially related to this time series settings. So I would really welcome the Mohammed to join this meeting, where we can explain what kind of GANs we have considered till now, and what has been the output and the performance related to the time series data. And specifically for the spatio-temporal setting, it's very difficult for me to like straight away say, hey, this is the kind of a GANs you can use it. I would be doing an injustice to the domain. So when it comes to this time series problem, we can elaborate more on the type of the GANs that you can use. And because the time I have a separate set of slides for that, so I can walk you through those different types of GANs, and tell the researcher how far he or she has been successful in using these GANs for this kind of time series data generation. So we would be more than happy to discuss on that.
Thanks, Sridhar. Yes, I personally was tracking your wiki page where you were surveying these techniques. So I think that's a very useful resource. I would strongly suggest anybody to look at that wiki page. Generalizing this question a little bit, I actually, let's step back from the challenge now and look at the generalized questions. You are using collect D, which gives a very strong structure for the data which is coming out of it, which is very nice, and it gives you an opening into this, applying this kind of techniques. Now, how about in the application space versus the infrastructure space, right? It's because collect D gives us data which is very specific. For example, as you showed, CPU, memory, network related data, right? So you would get this kind of